We have a torque wrench that we attach a rope at 9 inches away from the pivot point. We take a measurement using a cheap luggage gauge and did a force of 10.35 pounds force. We then take another measurement at 13.5 inches from the wrench pivot point. We get a force at the second point of 7.15 pounds force. In this problem, we want to solve for the theoretical force and distance when only given 3 of the variables. We will start by solving for force 2. We have to know the formula for torque, which is force times the distance from the pivot point. We assume that due to the torque wrench clicking at the same torque, the torque reading at 1 equals the torque reading at 2. So torque 1 equals torque 2. Expanding this, we get that force 1 times distance 1 equals force 2 times distance 2. Notice in this equation that if one side, the force increases, then the distance must decrease on that same side to accommodate this change and keep the torque equal. Also note that if the distance increases on one side, then the force will decrease on that same side. In this problem, to keep the same torque, being the distance at point 1 is less, the force must be greater, and the distance at point 2 is greater, so the force must decrease. Rearranging the formula to get the force 2 to one side, we get that force 1 times distance 1 over distance 2 equals force 2. Plugging in our numbers into the calculator, we get a force of 6.9 pounds force theoretical at point 2. Now let's solve for force 1 when given force 2 and distance 1. Rearranging the formula to get force 1 to one side, we get that force 1 is equal to force 2 times distance 2 over distance 1. Plugging in all of our numbers, we get 10.725 pounds force theoretical at the first distance. Now let's solve for distance 2 if we are given force 1, distance 1, and force 2. Rearranging the formula to get distance 2 to one side, we get force 1 times distance 1 over force 2 to be equal to distance 2. Plugging in our numbers, we get a distance of 1.086 feet theoretical for distance 2. For your reference, I've listed out all of the experimental and theoretical values. This video was using a gauge that was intended for static measurements and a torque wrench that had a low cost. This video was intended as a quick, cheap, and dirty example problem. This is why we see such a high experimental error. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Thank you for watching.